Developmental psychology is a branch of psychology that studies changes throughout the lifespan. Developmental psychologists study physical, cognitive, and social changes that occur from prenatal development through old age. This unit is divided into three different parts. Child development is one part, adolescent development, and then the development or changes in adulthood. This lesson is about the physical changes that occur during childhood. The next lesson will be on cognitive development of children, and the one after that will be on the social development or changes in childhood. When looking at physical development, we begin with conception. The unification of the sperm and the egg takes place in the fallopian tube. When conception or this unification takes place, the egg becomes fertilized. The fertilized egg is called a zygote. There are three stages of prenatal development. Stage 1 is called the germinal stage. This stage lasts from roughly 10 to 14 days. During this stage, cellular division is taking place. Soon after conception, the zygote, which is one cell, will divide into two. And then soon after that, those two cells will divide into four. And the process continues. As cells divide, they form into your body parts and your organs. During this period, the zygote will travel from the fallopian tube to the uterus. Once the zygote has implanted in the uterine wall, we go into the second stage, which is called the embryo or embryonic stage. This stage begins about two weeks and lasts until about 8 to 9 weeks. By the end of this stage, organs have formed and are functioning, with the exception of the lungs. The head, chest, abdomen, arms, and legs are clearly recognizable. Things like the nose, ears, eyelids, fingers, and toes are still developing. Also, at the end of this stage, the embryo will be roughly 1/2 of an inch in length and weigh about 1 ounce. So the next stage, which is called the fetus or fetal stage, will require or see a lot of growth, going from 1 ounce to 1/2 an inch to the average baby being born at 7 pounds in weight and 21 inches in length. 38 to 40 weeks would be considered full term. Around 12 weeks, sex organs may be seen on an ultrasound. By 20 weeks, the mother can actually feel the baby move. This is sometimes referred to as quickening. The fine details will also form during this stage. Like I said, the eyelashes, the fingernails. Lungs will begin to function at about 6.5 months of age. This is called the age of viability. After this stage, a child who is born should be able to survive on their own. Prior to that, in order to breathe, because the lungs are not formed, they would need to have some sort of assistance. The placenta is the lifeline for the baby. It is an organ that is attached to the top of the uterus and provides the fetus with nutrients and oxygen from the mother. The placenta is also supposed to filter out harmful substances and keep the baby safe. Sadly, there are many things that can cross the placenta and harm the child. We call these agents teratogens. They could be drugs, both illegal or over-the-counter medications. These medications can cross over and cause physical or cognitive damage to the developing fetus. One example was a drug called thalidomide. During the 1970s, this drug was very popular in Europe. It was intended to help women who were suffering from morning sickness. This drug had to be pulled from the shelf because many of the women who took thalidomide had babies who were born without limbs. A virus can pose a threat to the child as well. Somehow, a high fever that a mother experiences can interfere with brain development, particularly during the second trimester. There are studies that connect people with schizophrenia to their mothers having a virus when they were in the womb. Inhaled chemicals and x-rays can also affect the child's development. Smoking can cause a cleft palate and low birth weight. Another example would be alcohol. When an expecting mother drinks alcohol, she is at risk of having a child being born with fetal alcohol syndrome. Fetal alcohol syndrome causes physical and cognitive abnormalities. A newborn comes equipped with many inherited or automatic movements. One is called grasping. If you put anything in the palm of a newborn's hand, it will automatically grasp down over it. Suckling is the ability to suck, swallow, and breathe at the same time. The rooting reflex, if you touch their cheek on either side, they will open their mouth and turn in that direction, rooting for food. The startle-moro reflex, if a child experiences a sudden movement or large sound, their arms and legs will fan out and then they curl back in. After birth, a pediatrician will come in and test all of these reflexes to make sure that the nervous system is working properly. They're also born, most of these reflexes do fade as we get older. If somebody puts something in the palm of our hand, we don't automatically grasp it now, so a lot of them go away as we age. However, some we still have, such as blinking. If you blow air into a child's face, they will blink, but if you blow air into an adult's face, they will blink also. So that is a reflex that stays with us. At birth, the newborn senses such as touch, smell, taste, and hearing are pretty proficient. Babies have difficulty at birth hearing high-pitched sounds, but other than that, they have good hearing. Sight is the exception. At birth, the child can only see about 8 to 12 inches from their face, which is roughly the distance between a nursing baby and their mother's face. With each passing week, the child will be able to see a little further and further. A child will develop 20/20 vision by the time they reach 6 months of age. In addition, the muscles behind the eye are very weak for the first several months. They have trouble following an object with their eyes. They cannot move their eyes back and forth. Therefore, for the first couple of months, they have to turn their whole head in order to watch an object go by. At birth, babies cannot see it in color, only black, whites, and shades of gray. Many students often ask, how do you know? You can't really ask a baby what colors they see. Well, we have two types of photoreceptors in the eye, rods and cones. We are born with rods, and they allow us to see in black and whites and shades of gray. Cones do not develop until somewhere between 1 to 2 months of age. So prior to that, babies cannot see in color. Most babies can see the full color spectrum by 5 months of age. Newborn babies also have some preferences. Not surprising, babies prefer the sound and smells of their mother. After all, they have spent the last 9 months with her. They also prefer face-like structures. So they would prefer the object on the left as opposed to the one on the right because it appears more like a face. Again, how do you know what babies like and what they don't like? Here, psychologists use what's known as gaze duration. The longer a child looks at something, we think they're more interested in it. So that would be us as well. You know, as we get older, if we see something and we find interesting, we will pay attention to it longer. And babies are no exception. Babies get bored with the same old stimulus over and over again, and they stop responding to it. This is called habituation. For example, as you see in the chart, you show a child an image, they may look at it for about 40 seconds and show interest. The second time they see that same image, like, yeah, I already saw that. So they only look at it half as long. So we know that babies like new or novel things, but we are like that also. At this point in the video, you're probably thinking, when is this going to be over? I'm getting very bored with the same old voice. But if somebody else were to start speaking, then we may take interest. because we, as well as babies, do like those new or novel things and get bored with the same old stimulation. Physical growth, or the biological growth process, we refer to as maturation. So the baby is maturing. Whenever we look at these physical milestones that children go through, we have to recognize that the sequence is universal, meaning every baby will go through the exact same sequence of physical development. However, the timing varies. So the first milestone that the baby will conquer is being able to control the head. When a child is born, their head is very large compared to the rest of their body. The neck muscles are very weak, so you have to support the head for them. They cannot hold their head up. After a couple months of age, they're able to control the neck muscles and hold their own head up. The next physical milestone that they will conquer, when they're laying down, they'll be able to push themselves up. Soon after that, they'll be able to roll over on their back, but then they're stuck for a while. But about a month after they're able to roll on their back, then they learn how to roll from the back to the belly. And then they can keep rolling, and you have to make sure everything is childproof because they can just roll away. By the age of about 6 months, a baby can normally sit supported with pillows. By about 7 months, the abdominal muscles are usually fully developed, and a child will be able to sit unsupported. A child that crawls will usually begin to crawl between 8 to 9 months of age. Some babies crawl, some don't. Some are just content to just sit there. Usually by 10 months of age, a child can stand supporting, holding on to something. And usually around 12 months of age, a child will actually learn how to walk. Now, these are typical milestones that a child will go through, but not every child will go through them at the same time. And parents often get very frustrated about this. Some children will be able to walk by 11 months of age. Some children cannot walk until they're 13 months of age. Until they are physically ready, they cannot conquer these tasks. At birth, a child's neural connections or brain is very immature. As the child gains new experiences very rapidly, new neural networks will grow. We cannot remember things that occurred prior to the age of about 3.5. And this is because of the immature neural networks that we have, and they're not connected to certain regions that store these memories, like the hippocampus. This is referred to as infantile amnesia.